to a great extent managed to bring Marathis around the world on one platform with the basic theme of education and entrepreneurship. And in this, we do run the series of webinars and series of think tank meetings so that we can share our knowledge, wisdom for the benefit of our society, benefit of our younger generation, as well as to benefit all of us. Today, we are very pleased to have Dr. Ameet Joshi with us. Dr. Ameet Joshi, welcome, and thank you for accepting my request to address Garje Marathi members. Dr. Ameet Joshi is renowned in a field, a scientist in a field of machine learning, AI. He has done PhD in electrical engineering from Michigan University. And other details about Dr. Ameet Joshi I have shared with you on my welcome link, welcome email. So now I request Dr. Ameet Joshi to start today's proceedings. Before that, I would request everybody to stay in a mute position. Please do not share your screen. And if you have any questions, please post them in chat at the end of Ameet's presentation. Either myself or somebody will call you to ask your questions. Thank you very much again. Over to Dr. Ameet Joshi. Dr. Ameet, we are recording the session.
Yes. Thank you very much, Anand. It has been a great honor to have a chance to present on this platform and being part of the Garje Marathi community also. So thank you. Good morning, good afternoon, good evening, everyone. As they are joining from all over the different places around the world. Let me start sharing my presentation.
Yeah.
Let me know when you see the first screen.
We can see.
Okay, great.
Great.
So hello everyone. Today I'm going to talk about artificial intelligence and its applications in business domain. So artificial intelligence is like a very well studied and discussed topic. We already had some talks around that topic before. So I will not be going in a lot of details about AI itself, but I'm going to focus more on how it is being used and it is evolving in the world of business. So I'll give some context before I delve into the subject. So let's start. So Anandji already introduced me. I just give some background briefly to create a context around my background. So where I come from for this particular topic. So I did my PhD from Michigan State University in the topic of non-destructive evaluation. Then it was primarily focused around the applications in the energy sector. Then I continued my research in Microline, which is based in northern Michigan, in oil and gas industry and applications of AI for that. Then I continued my journey into home energy sector and applications of AI in that in Belkin. And then I'm at Microsoft currently, and I've worked on multiple different areas in AI, including being in business domain. I recently published a book on machine learning and artificial intelligence with Springer. This is essentially coming from the background that all the folks that are entering into this field from as a business professionals, they often face this gigantic block. But to start is always a problem. So this book is kind of intended towards that, to give general introduction to the topic, and then you can continue with your journey into any specific areas from there. So with this context, let's get to the topic. So let's first talk about artificial intelligence. So artificial intelligence is a multifaceted, multidisciplinary area that finds its roots in many different research areas, starting with mathematical optimization, statistical analysis, computer vision, and many more. And then you also introduce the way human intelligence works, and then couple all this with computer science, and that essentially leads to artificial intelligence. So whenever you see artificial intelligence, it's combination of all these areas. So it's depending on the application and domain, it can be interpreted in variety of different ways. Today I'm going to give some like fundamentals about AI, what exactly it means, how it pertains to machine learning, and then in business application. So let's come to like the definition. So what is AI? So in the 20th century, great scientist Alan Turing, he envisioned a test that was then called as Turing test. So what he envisioned in this test is that there is a human questioner that is sitting behind a desk, and he cannot see the person or the machine, whoever it is that he is interacting with. And then there are two respondents. One is actual human, and one is a computer or machine. And he's sending questions through whatever medium, and he's getting the response from the respondent. uh, I think I'm hearing a lot of noise.
Yeah, I will unmute all, and then you I will mute all, then you unmute yourself again. Other thing is that
Okay. Okay.
please have a full screen. You are having, I think, a smaller screen, Amit. Make it a
Oh,
now it,
really?
yeah, that's what somebody commented. That's what somebody commented. Make it a full screen.
Okay. Maybe it's the aspect ratio, because in my screen
Okay.
I'm presenting full
Okay.
screen.
Perfect. Please carry on. Please carry on. Please
Okay.
stay mute, everybody. Yeah.
Okay. Thank you. So the human questioner then asks questions and get responses from options that are hidden from the questioner. And then after sufficient amount of questioning and understanding the responses, if the human questioner feels that whoever is responding is a human, and if that is indeed a machine, then that machine is called as an artificially intelligent machine, or it's basically AI. Uh, but that's not what we call AI with modern sense. That's kind of a fundamental shift in the way we think about AI, and let me get into that. So, what is the modern definition of AI? So, first of all, we know it's a machine and not human. We are not even, trying to mimic humans in machines, because God has created sufficient humans. We have populated almost the entire earth, and all the things that are possible to achieve with human talent and capabilities, we are already doing that. So what we are trying to use AI for is to augment and complement what humans can do, what humans can think, and so on. And that brings us to what are the things that are expected out of AI, modern AI. So things where humans are very slow, or things where humans are just physically incapable of doing those things, where human life can be threatened and humans should not be involved in the things, or there are just too many humans are required for the task and it becomes impractical. Or this is one of the most important aspect that we will see later on in business domain specifically, that human emotions can affect the outcome in the undesired way. And the AI is unbiased because it's essentially data driven. And I think operations that need to run 24/7, 365 without interruption, where again humans can have difficulties doing that, and so on. So essentially what we are trying to do with modern AI is to expand the capabilities of humans, make human life easier and more rich. Now, let's look at the connection between AI and machine learning, because those two words are always used together, but those are not exactly the same thing. They are kind of related, and they need each other. So, what is ML? So, ML essentially stands for, it should actually be read reverse, that learning machines. So, machines need to learn to do things that the person who made the machine may not be able to do. So that's one of the fundamental aspect of AI, that the machine is once it starts operating, it is going to face things. It is going to face some of the problems that it has not seen before, but it's still able to solve them. And with this, there are are two concepts that always come into play, and many times they are misunderstood, misused. So I just want to give some clarification around those two concepts, and they are algorithms and models. So algorithm is a mathematical construct that defines how the input is processed to solve a certain optimization problem to generate desired outcome. Now that's like a theoretical definition. So in a very simplistic terms, we can imagine algorithm as a set of equations with variables and unknown coefficients. So we have equations with variables. So the variable is what is the input, but also the coefficients, like how the input is tuned and operated on to reach the output, that also is unknown. And what model is when an algorithm is presented with a set of training data. Now training data is always like a labeled data, and it's a very common term that you will see in this field of AI and ML, where we always need a starting point, a sort of prerequisite or some knowledge of the problem that we want to solve, which includes inputs as well as the desired outputs based on those inputs. And when this kind of training data is applied to the algorithm, it basically learns those coefficients of the equations. So the variables are still unknown, but it learns the coefficients. And once we have learned the coefficients, now we have a set of well-defined equations, and then the model is ready to make the predictions on similar type of data, which is previously not seen. So it's again, remember, it's a very simplistic representation, but it still kind of conveys the point and the differences between what is algorithm and what is a model. Now we understand now what is AI, what is ML, what is the scope of problems that it can do, but it's also important to understand its limitations in order to effectively use it. And modern AI also is with limitations. It is not without limitations. So in order to understand the limitations, let's consider the levels in AI. Now, this is a really fundamental question that I'm going to talk about. It might appear a little confusing, but uh, bear with me. So the first level is know what we don't know. So it can appear confusing, but let's take an example to make it simple. So let's take a problem of, say, detecting images of cats, like detecting cats from an image. So now we don't know how to do that, but we know what we want to do. So we are given an image, and whether we want to classify that as whether the image contains a cat or not. So what we need to do is we need to gather a lot of images, preferably half of them that contain cats in variety of angles and shapes, and different types of cats and so on, with different backgrounds, and then another set of images which does not contain cats, and we need to have the labels for them. So once we have that kind of a training data, we can select an appropriate model or algorithm, and then we train that algorithm to build a model that can then detect the cats from the images. Now, this is a problem that we don't know how to solve, but we know the problem. So this is the kind of problem that the modern AI is very comfortable with. And the second level of problem is much harder. And currently, there may be some papers, research papers published on this. But in general, we have not solved this particular problem with AI, and that is don't know what we don't know. So what does that mean? So it means that in future we are going to encounter some problem. We don't know which problem, but we need to solve it. Now, one can ask that how can we solve a problem that we even don't know about? But believe it or not, humans are extremely good at this. We are born to do this. So every human baby that is born is completely unaware of the situations that he or she is going to face in his or her life. But we do learn from mistakes. We do mistakes, but we learn from them, and ultimately we solve the problems. So let's take an example of this current pandemic of coronavirus. So 2 years back, nobody anticipated any of that, maybe except for some visionaries like Bill Gates, who said that the next biggest problem the world is going to face is not a world war, but a virus. And but still, it was still quite vague, and we didn't know what to expect. Even Bill Gates didn't know it's going to be coronavirus or how it's going to spread, what are going to be the symptoms, and so on. So we are facing the problem. We made some mistakes. We are probably still making some mistakes, but vaccines are under productions, and in a matter of months we'll solve it. and in year or so we will forget it. It will be history. So we will solve the problem even if we were completely unaware of the problem few years back. So that's the kind of level that humans are like born to do, but modern AI still is not able to do it. So it's kind of a fundamental limitation that we should understand. So this is the kind of levels and limitations that I wanted to talk about. And with this, now let's get on with the applications of AI in business domain. So this is just a pie chart showing the spread of different industries in United States. It can be a slightly different in different countries, or but essentially what it says is that there are tons of different industries, and every industries come with their different processes, different methods of data gathering, different outcomes, and so on. But there are still some fundamental processes that are common in all the businesses, and those are the ones that are primarily targeted for as an application of AI. So whenever we talk about business application and AI, there's another term that always comes, and that's big data. So let's start with this. So in businesses, we always face this reverse problem. There is a more data and less intelligence. So as we saw before, the origin of AI and ML lies in a deeply rooted theoretical research in mathematics and statistics and so on. And in all these problems, we had a lot of algorithms, a lot of techniques, but we are always struggling to get a good amount of labeled data. And that's the main problem we face in theoretical academic setup. But in business, the problem is reverse. There is ton of data that is gathered through a lot of business processes that are already doing that job, but that data is untapped. That whole potential or intelligence that the data can generate is untapped so far, and that's actually a good problem to be in as far as AI is concerned. Then another notion that comes is we can always get more and more data, but what is big data? Now, the big data is typically linked with the amount of data that like can or cannot be realistically processed on a single machine. So if we can solve that problem, load the entire data and process it on one machine, then it's not a big data. But if we need a cluster of machines and so on, that's typically a big data. Now with the exponential growth of silicon, we see that the capabilities of machines are like expanding every day. But even in today's terms, when the data is say like hundreds of gigs or more, we can broadly consider that as big data. And the third one is, and that's basically the key thing that is really driving the growth of AI in business, and that is the data-driven decisions versus human decisions. The human decisions are always tainted with bias, emotions, stereotyping, and so on, while data is absolute. When we have a number 20, whichever way you look at it, the Marathit lilela asू दे, किंवा it is in English or Roman, or we see it from different angles, it's still number 20. So it's absolute. So all the decisions that are driven by equations based on data are also absolute. And that kind of is critical in a lot of business applications where we need to be objective and not driven by emotions. Okay, so when we look at the data that the businesses deal with, there are always multiple sources from where the data comes. It can be CRM software, it can be surveys conducted on web or emails and so on. It can be data coming from social media like Facebook, Twitter, LinkedIn, there can be many other sources. But in order to make the full sense of whatever entity that we are dealing with, let it be a product or a company or customer, we need to unify the data coming from all the different sources in a meaningful way to understand the full picture about that entity. And so when we are doing that, it's extremely important to know that as far as machine learning is concerned, it is always garbage in, garbage out. So if the data coming in is too noisy, we are not going to get good results. So whenever the data is coming in, it's unified, it needs to be understood. So this what is meant by schema understanding is that whenever say, let's say take an example where the data contains say a column with dates. Now, what are those dates? Are those birth dates of some person, or is it that date when certain item was purchased, or is it when the survey was conducted, what that date means. So understanding semantic meaning behind every column of the data that is coming in is extremely important, and that's kind of what we call schema understanding. Then missing data prediction. So many times the sources like social media or surveys, the data that is gathered from there is not complete. Like a lot of people are missing a lot of fields and so on. But in order to effectively use machine learning on that, we need to have the data fully populated. I mean, the algorithms can still work with some missing data, but we try to fill as much as data possible. And some of the data is relatively easy to fill with. For example, if we know the address like city and state, we can easily fill out the postal code automatically, and so on. Then exact versus fuzzy matching. Now, exact matching is like string matching. So if we have an email address, for example, simple string matching will work. Rather, we should only stick with exact matching, because the email address abc at hotmail.com is completely different than say ab@hotmail.com. Although there is only error of one character, but it's a completely different email address. But that's not the case with, say, for example, addresses. So in addresses, there are like terms like roads and avenues, or the states, which are always abbreviated into, like states can be abbreviated into 2 letters, or roads and avenue. They have all their unique way of making acronyms. Also, the names in Western world, the names also can have acronyms. Like Robert can be called Bob officially. So those are some of the things that we need to take care when we are matching the data coming from different sources, and that can be handled by the technique called fuzzy matching. And finally, when we have matched all the data coming from different sources based on a specific entity, then we actually need to merge all the data to look at the unified information. So that's kind of marks the first step in data, and we start to make sense out of it. Now let's look at the main functional area in business applications, and where AI can be of use. So these are the like marketing, management, operations, marketing, accounting, and finance are considered like a top functional areas. But out of those, these three areas is where the more data-driven decisions are going to make more difference, or rather required, and that's where the AI is primarily focused, while management and operations is still quite human focused area. So in this talk, I'm particularly going to focus on the marketing applications, which are also, like, I think, more varied, more studied, and maybe, I have better experience in them as well. But I will go over some of the applications in accounting and finance as well. So if I want to list the main applications in AI from specifically marketing perspective, they can be churn prediction, followed by customer value, personalization and recommendations, understanding customer feedback, and segmentation. Now, let's look at the first two aspects together, because together they make more sense and they can be more valuable. So here is a quadrant, like with x-axis as customer value and y-axis as likelihood of churn. So on the first block, we have low value and low chance of churn. So these are the customers that are bringing relatively low value, and they are also not quite likely to churn. So they are loyalist, in a typical business definition, but they are not providing good value. So we can use some more personalization and recommendation for them to move them to the green spot, where they can be high value with low chance of churn. The second quadrant is low value and high chance of churn. Now, these are the some are less important from marketing standpoint, because they are likely to churn because they are reducing their engagement with the business, but they are also bringing low value when they were engaged. So they are relatively less important from the marketing standpoint. The green quadrant is the most important and most valuable quadrant, also called as champions in some definitions, where these are high value customers with low chance of churn. So they are loyalist also, and also they are bringing in high value. So they are great. We need to do more personalization for them. It's extremely important to maintain these customers, and these are the ones that are the most valuable or most important from marketing standpoints, that these are the customers that are bringing high value, but in the recent terms they are reducing their engagement with the business, and consequently they are at high chance of churn. So these are the ones that marketing campaign should be really focused on, to give them more incentives, more promotions, to bring them back, because in general acquiring new customers is extremely expensive rather than maintaining existing customers, and especially maintaining high value customers. So this is the main driving force behind prediction of these metrics. Now, how they are dealt with AI and ML. So before that, we need to understand how they were handled before. So typically, a marketing expert would create a heuristic model based on his limited set of information, or based on his past experiences, and that whole model is going to be biased because of his personal experiences. No fault of himself, it's just the way humans work. But when we use AI and ML based models, what we can do is we can take the holistic picture by looking at the unified data, and we just run the algorithm and do the optimization and create the model. And that can make unbiased predictions with much broader scope compared to the ones that is acquired by previously done by the marketing experts. Now, let's look at the next one, which is personalization and product recommendation. Now, we cannot really talk about this subject without mentioning Netflix. Netflix really pioneered the concept of personalization and product recommendation when it started the online viewing of their video content. According to Netflix, 80% of the content that is watched comes from recommendations and not explicit search. And they also claim that their personalization enables us to create more than 250 million tailored experiences. And it's not really a far-fetched when we look at the actual numbers. And Forbes almost calls it Netflix effect, where they have more than 160 million subscribers and growing, with more than 7,000 shows and movies. The number can change drastically in the regions, but if you just take a combination of these, it's 250 million is actually a very small number. So having a way to kind of tailor experiences to such a broad audience with such a broad content is just impossible, if even if we apply thousands of humans. So when we deal with product recommendation and personalization, machine learning has absolutely no alternative. And it didn't even exist to the level that we deal with today before ML even came into the picture. Now, another aspect of marketing is to understand the customer feedback. And that involves some different areas in machine learning that focus on natural language processing. So typically the customer feedback, I mean, it can come in like just how satisfied are you, 1, 2, 3, 4, 5. And that is almost numeric and it can be processed easily. But typically the customer feedback comes in the form of free flowing text. Like it can be comments, or they can be tweets on Twitter, or posts on Facebook, and so on. And what we need to do from that is to extract sentiments. And the typical areas where we get this input is tweets or survey feedbacks. Now let's take a few examples of tweets. Say, here is one simple tweet saying that I'm happy to choose Delta Airlines. In spite of delays, I was treated well. So it's a fairly straightforward response, and we can make it easily classified as a positive response. And it's general talking about in general experience with the travel. But there can be some more complicated, sarcastic remarks it's sad that April 1st is the only day of the year when people actually question validity of the news they read. Now, whether to call this sad because it actually has a word sad in it, or is it funny, or is it angry? It's hard to say, and that's where the skills and the power of natural language processing really comes to help. The another aspect of understanding customer feedback also includes keyword extraction. So it's not just sufficient to extract whether the sentiment is positive, negative, but we also need to understand what exactly the feedback is about, because typically the companies have multiple categories of products and services, and the feedback is gathered all across the domain. So we need to understand the feedback sentiment as well as which category it belongs to. So for example, if we apply the NLP technique, it can extract certain keywords from it, like it's about, the first is about happy and delayed and being treated well, or in second it's sad, validity, news, but it's still a lot more processing to really understand the sentiment in this case. So what the NLP really gives us is it gives us a quantitative measure of customer satisfaction. So with sentiment analysis and keyword extraction, we can have almost a numerical representation of every text feedback. So this particular feedback talking about this category and has a sentiment positive or sentiment 60% positive and so on. So once we have that kind of quantitative measure, we can use then other models to make data-driven decisions and not just stick with some specific comments and get trapped into the bias and emotions of humans. So once we have identified all these quantitative metrics, then the next step in marketing is essentially segmentation, or identifying the cohorts of customers that they want to target for specific campaigns and what kind of promotions they want to offer. It kind of marks the final step before it leads to taking actual actions. And it can typically start with simple rules, I want to have the target the customers with this much of future value and this much likelihood of churn and so on. But these rules typically are insufficient to get exactly the size of the data and exact combination of customers that they want to target. And that's where again AI and ML techniques can help. Also, they can remove stereotyping. They can also identify some hidden patterns and trends that marketing experts can overlook. And also, it can provide automatic segment sizing based on the budget that particular campaign has. And also, it's scalable. So once we have the model, then we can run multiple campaigns, and all it needs is running the model again. So with this, that basically gives a good idea about the applications of AI in the field of marketing. Now let's look at some of the applications in accounting and finance. The main application is forecasting, which can include demand forecasting, sales forecasting, or trend and seasonality forecasting. Now, this particular area was heavily studied, is still heavily studied in the domain of statistics. And there are a lot of sophisticated statistical models that do the job of forecasting. But the recent advances in deep learning area, specifically recurrent neural networks, are showing vast improvements over some of those models and can automate this process of forecasting. The other area is process automation. It can include chatbots, call center automations. Another important area is security, detecting the frauds and suspicious behavior across different activities. So when we are dealing with millions of activities that are going through online purchases and so on, how to identify the fraudulent activities and suspicious behavior. It's almost impossible with simple humans or even with simple heuristic models. So very sophisticated ML models that are trained using the past examples of frauds and suspicious behavior can significantly improve the detection in the future. Also monitoring the credit of different people. And also another emerging area is trading and portfolio management. So another thing that I would really like to focus on is explainability in AI. Now, typically, when we apply the machine learning models, they are very complex mathematical constructs. Like I gave an example of a set of equations, but that was an oversimplification. Typically, we have a much more complex mathematical model, mathematical algorithm behind every application of AI. And when we apply that, we get results. Okay, we can also provide metrics that how accurate that particular model is, what is the precision, recall, a lot of different metrics that we can give to prove that this model is good. But how can you impress, or how can you inspire confidence in the minds of humans who were doing the job before? So they first need to understand, like, I'm not just going to believe just because you show me the metrics are so and so that you are doing good. And that's where the problem comes, because it's very difficult to explain what is going on inside of a machine learning model, and that's why they're typically called as black box. Recently, there has been a lot of innovation about making this black box more like a glass box where we can actually look and see what's happening inside. Not necessarily to the very level of every bit processing, but to at least a generic level where, okay, so for example, we are talking about churn prediction. So we know that, okay, the model is predicting that this customer is likely to churn with confidence of, say, 80%. But then it also gives explanations. So it gives some features like changes of values in certain features, like the number of items it purchased over last few months declined, or the total amount of purchases that he used to make in last 5 months was about $100 average, and in last 2 months it has reduced to $100. So basically, those kind of explanations can inspire confidence into the minds of the human users, because ultimately humans are going to use these models, and they should have confidence in the models. And obviously actionability. So when we know that what are the specific reasons that certain customer is going to churn, those reasons can also lead to what action we can take. So if the reason is about shopping less number of items, then we can probably target about marketing such that he buys more items. If it is the cost of the item, then we can offer discounts, so things like that. So that's another important use and application of explainability in AI. And it also makes the algorithms more digestible to the person who is not super conversant with the technology. Now, this is one of the last topic that I would like to talk about today, and that's about democratization of AI. Now, as we saw before, a lot of techniques in AI have evolved from deeply rooted mathematical and statistical background, but in business domain, most of the users are not going to have that background. So, how can we deal with this problem? So let's look at the different personas that are typically encountered in the business domain. So the first one is, say, business user or business executive. So this is a person who has almost no knowledge of AI whatsoever, or even data manipulation for that matter. But this is the person who knows the business domain very well. He knows what exactly are the problems that we need to solve. He knows the data. He knows where the data is coming from, what exactly it represents. He knows the schema and so on. Uh, but he has no knowledge of AI whatsoever. So what can this person do? Then another persona is going a little bit closer to the data, in the sense business analyst or data analyst. So he is a person, again, does not have a good knowledge of AI, but he knows data manipulation, like SQL, for example. So what these types of personas can do? So a lot of platforms currently offer what we call as out-of-box models. So these models are customized. They are customized to specifically solve certain types of problems in business, like churn analysis or lifetime value of a customer or sentiment analysis and so on. So these models don't need any input from the user as to which algorithm to use or how to tune the algorithm or so on. All input that is required is you connect the right set of data, and that's it, and give exactly what you want to predict, and the model will do the job for you. So this kind of approach is ideal for these types of personas who have absolutely no knowledge of AI. Then we go one step further where we have a data scientist. He knows the AI models as black box. So he's familiar with most standards ML algorithms and techniques. And now most of these algorithms are now readily available in the form of open source libraries in Python or R or even C and Java for that matter. So this data scientist persona is familiar with those libraries. He understands what the different algorithms are expected to do. So this is a person who's not necessarily understand the nuances of how the algorithm is created or the details of maths behind it, but he knows how to use the algorithm as a black box. What data is required to train the model, in which specific scenarios which model can work better, and he's also comfortable with tuning the model so that its performance or accuracy can be optimized. Now for these type of persona, there is option of using Python or R packages for machine learning libraries. One example is scikit-learn. And then we go to the last persona, which is very rarely seen in the field of business, which is a machine learning scientist. So this is a person who has like a PhD in maths or statistics or some computer science or electrical engineering and knows the theory of machine learning algorithms. So he not only looks at them as a black box, but understands the innards of that black box. And this is the person who can actually build custom algorithm to solve specific business problem. So for example, when Netflix came up with this concept of personalization, that was actually a brand new problem in the field of machine learning. And they use the techniques, what is now called as collaborative filtering, to solve that particular problem. So they definitely use machine learning scientists to solve that problem. So this is again the companies that are super focused on AI and super focused on a very niche problem to solve can actually go to this level and actually build a new type of algorithm to solve certain custom models. And tools for them are just basic programming languages like Python, C, Java, even R. So this basically shows that although AI started as a very complex mathematical tool emerging from all the sophisticated areas, in business domain it is accessible to pretty much each and every persona and can make full use of that based on their background knowledge to get the best out of them. So yep, that's all I wanted to have, folks. Thank you.
Presentation. Thank you, Ameet. That was a great presentation. There are some questions which I would like to invite Mohan Ghatke to ask his question. Mohan, can you unmute yourself and ask your question? Hello, Ameet. Can you stop sharing your screen, please?
Yes.
Yeah.
Just a moment.
Hi. This is Mohan. I just was wondering for whether any of the governments are using this AI or ML for their governance or building up an economic model for the country.
I don't have obviously first-hand information, but my speculation is 100% yes. So as you can see, with the democratization of AI, pretty much every medium-sized to big-size industries have absolutely no excuse to use AI. Even the small-scale industries can use AI. So if you're talking about the company or the organization as sophisticated and as resource as governments, they should be using. There is no excuse in that.
Okay. Milind Kanetkar, Mohan, is your question answered?
Partly.
Okay. I think you can share. You can share
more details, but
yeah, we can
as I
share
said,
the
I
email.
have not personally worked in the government sector, so
Anyway, we
No,
can do it over emails also, past this
Okay.
thing. There is a question by Milind Kanitkar. Milind Kanitkar, can you read your question? Ask your question, please.
Yeah, sure. Thank you, Amit, for a wonderful presentation. So, in my opinion, based on the things that you went through, the predictive models and prescriptive models are kind of interchangeable, or they feed each other, in my opinion.
mhm.
Just wanted to know is what kind of industries tend to use predictive models more often than the prescriptive models, and if you can touch base upon based on your experience or your insights, I think that will be great.
Okay.
That's a very good question. So, predictive versus prescriptive is always a very important discrimination between the use of the models. Predictive models are basically trying to predict why certain things are happening, like churn score, for example, or customer lifetime value. Prescriptive models, on the other side, are one step forward, where we have already understood why certain things are happening and we want to prescribe how to address those problems or how to address that situation. So I think use of prescriptive models is more based on the confidence that particular organization or company has in their models to directly use the prescriptive models to take the action. So in case of Netflix, for example, the recommendations that are provided, those are like prescriptive models where they are directly giving those recommendations and there is no human who is governing those recommendations, but they are directly shown to the user. And they have a model that is mature enough that can actually run on its own without moderation. So once you reach that level of confidence, then prescriptive models can completely take over and replace the job that was probably done by humans before.
Okay. Kaustubh Borimbe says it's amazing session. There are many compliments, Amit, but I would like to invite Datta Nadkarni to ask his question. On 8th August, we have a webinar by Datta Nadkarni also. Datta Nadkarni, over to you.
Hi guys, Ameet Chan Kelas, Uttam.
Thank
I
you.
wanted to ask if you have any comments on the area of predictive treatment in medicine. And there is a lot of data, but not enough analysis, not enough models.
That's very true. So again, application of AI in medical industry is one of the top areas of research right now. But when we deal with the industries that are as sensitive as medical, because in for example Netflix, if you make a wrong recommendation, the worst that can happen is, okay, I will not watch that movie. But when you are making predictions in case of business domain, the trade-off between your accuracy, like precision versus recall, that's extremely important. So you have to be extremely accurate, near 100% accurate, to be actually able to use. So there are a lot of companies and a lot of efforts are being made into this area. But when it comes to using those insights to replace a human, it's a very sensitive area, and I don't think we have reached a level that we can very commonly start using it. But I'm already seeing like a lot of nurse line, for examples, they are replacing it with automated agents. You input certain symptoms, and it will give you some over-the-counter medicine recommendations and so on. But when it comes to like meeting the actual doctor, we have not reached the level of
Now there is two
that.
comments I want to make. One is companies like 23andMe, they took your saliva sample and identified your genetic code and figured out if you or me or whoever had a predisposition for certain diseases. The AMA got into a legal battle with them saying, we are doctors, we know how to tell patients. And 23andMe came back saying, you don't know anything about molecular genetics. So anyway, so that is one
That's
example.
correct.
They're
Yes.
still
So
working it
no,
out.
so that's another point. So what these tools are actually doing is they're helping the doctors make better decisions. So
Correct.
you always have doctors, they basically see the past records, but now with the past records, they can also see the predictions that are being made by some of the ML models. or like the information that is gathered from 23andMe kind of databases to actually make the doctors make even better decisions.
Correct. Second comment is based on
Okay,
retinal
okay.
pictures. Google is learning a lot about high blood pressure, coagulation in the retinal surface, etc. Any experience? Microsoft is also jumping into that area. Any comments there?
So
No comment.
I would like to keep my Microsoft side separate in this chat. So yeah, I think we can take this
Thank you.
offline.
Thank you.
That's his employer. Yeah. Anyway, we have limited time. Amit, do you have another 10-15 minutes? Yeah. Okay.
Yeah, I can.
There's
I
a
can.
question by Ajay
Uh,
Bam. Ajay Bam is yeah. Ajay is
yeah. So Anand,
Garje Marathi. He had his own webinar, which was highly appreciated. Over to Ajay Bam. Ajay Bam, please
yeah.
ask your question.
So Ameet,
Hello.
I train machines. I train machines to watch millions of videos on YouTube to help brands match video reviews to products. So it's a problem. We analyze video, text, audio, and images. And so my question to you was, what is the status of sentiment analysis? So we actually we analyzed the audio for sentiment, positive and negative. And I'm curious, what's your take on that, on where that is right now?
So sentiment analysis is becoming quite mature, especially with respect to audio. Detecting sentiment from video is, I think, it's still quite in infancy, and it still needs a lot of more research. But as far as audio is concerned, again, when we talk about audio, there are two aspects. One is the actual audio file, which can have the actual tones and the variations in the phonetics, while the text conversion of that audio, where it is purely just English language text. So as far as the English language text is concerned, that technology I can say is quite mature. But again, there is a limitation that, for example, if we train the model using data from like survey results, and then we try to apply the same model on tweets, it can fail completely, because tweets are like so haphazard. They don't even have proper grammar in it. They can have stars and a lot of unstructured text. And so even with really good algorithm, it is very important to tune that algorithm for the specific domain where it is going to be applicable. So that's so we never are going to have like a very generic sentiment detector that can be applied to the text that is coming from articles, as well as surveys, as well as tweets for that matter. So we have
Okay.
a good set of algorithms, like especially the new techniques that you might have heard, based on the BERT, the transformer algorithms. Those have really pushed the way we handle NLP and overall analysis followed by that. But it's extremely important to train the model for specific domain.
Is there
Okay.
just one follow-up question on that? Is there a particular school around the world that's focusing on sentiment analysis and has done really good job at it? Any particular?
Pardon me, I missed the first part of your
I
question.
said, my question is there a particular university around the world that is simply focusing on sentiment analysis and really has done a good job at it? So what we analyze the audio, we are able to do sentences and keywords, but keywords we can do keywords better than sentences right now. Because to your
Right.
point, even breaking down the audio into sentences is a difficult problem. So I was just curious.
I cannot name a single university. I know like at least a dozen universities who are like very heavily focused on this area. And with some of the Google's advances, that area has really gained a lot of traction and popularity. But I wouldn't say you. So that's another problem with machine learning. So open source languages, I mentioned about scikit-learn, but I've attended so many conferences, and in every conference, every university comes up with their own library of algorithms, and it's just impossible to keep track of all these libraries. And I'm sure there are tons of libraries out there that can outperform every model in scikit-learn, but it's just impossible to actually gather them all together with the right context.
Thank you.
Amit, let me unmute myself. Yeah, Amit, there are a number of questions,
Okay.
and we can go on, go on. There is no problem. I will copy paste all these questions to you afterwards. I'll take two or three more questions, and after that, I'm going to request Sri Ajit Zawkar to make his comments on today's presentation. Ajit Zawkar, you know him. He is an expert in AI. Anyway, first question is I'm going to read is from Dr. Vaibhav Patankar. Vaibhav Patankar, just before the meeting, I talked to him. Vaibhav Patankar is your father's junior in BARC. Okay, over to Dr. Vaibhav Patankar, please.
Good morning, Ameet.
Good morning. I
The
mean, good
talk
evening.
was very good on machine learning. And I just wanted to know because you have also done a lot of work on non-destructive testing. So now under NDT, imaging is now a regular practice. And then large amount of data is generated either it is in ultrasonic imaging or radiography imaging or even eddy current imaging also. So now is it possible to apply machine learning for NDT, particularly imaging, because where large data is generated?
Absolutely. I mean, NDT is actually another poster child, I would say, for applications of machine learning. So, when I actually graduated, I never heard the word machine learning as such. It was just signal processing, image processing, computer vision. But all these applications are like perfectly lie under the umbrella of machine learning. So again, this is a very domain specific problem. So the kind of problems that we will see in ultrasound images will be completely different compared to eddy current images, compared to magnetic flux leakage, which I was actually working in. So we need to first understand the domain specifics, in that particular area, and then we need to apply some initial pre-processing of the data to denoise and identify certain regions of interest and so on. And then we can apply various machine learning tools. Like if it is a classification problem, we want to classify whether it is of type A, B, C, D. We can use binary or multi-class classifiers. If it is like a regression problem where we want to estimate some kind of a linear variable, we can use regression type of problems. So I think these two domains specifically match very well with the pretty much all the applications of NDT. So having a pipeline that includes some data pre-processing followed by classification or regression type algorithms. It can include like support vector machines to neural networks to even deep learning. So those can have significant impact on any of these applications in NDT.
There are two questions. There are two questions where the people they are saying they do not have microphone, so they have typed that to me. One is by Sanjeev Bramme. He is saying that can AI be used in mortgage services in financial sector? And there is a question by Doctor. Please unmute. Please mute yourself, everybody. Sorry to instruct that over again and again. And there is a question by Dr. Anita Khan, which I'm trying to find out. Anita Khan says, sentiment management, how is it used in helping psychological emergencies? How AI you can use in psychological emergencies? First question was by Sanju Brahme. How AI can be used in the mortgage services in financial sector?
Okay, so let's look at the mortgage sector first. So, can you be a little bit more clear? Like, I can see definitely, like, it credit monitoring or creating the terms of mortgage. There are a lot of different parameters that need human decisions in this particular case. And whenever we can quantify the decisions that are being made, we can definitely apply machine learning to make them data driven and more unbiased and also more optimal. So if we can give concrete examples, I can give
I
you
will,
very specific
yeah,
points.
I'll connect him to you over email. The Anita Khan's, after Anita Khan's question, there are many other questions, but I will just, what I will say, I'll connect those to you via email and you can answer them directly. So you can answer Anita Khan's question, psychological factor.
Yeah. So again, as I said, when you talk about emergency, it kind of becomes a sensitive area. And so I don't think in general ML has reached to that maturity or that confidence where people will just accept the outcomes of that. But whoever the psychos the doctor who is analyzing that particular patient can definitely get a lot of help from the predictions of the particular person's psychological state by analyzing his comments or the remarks in an email or written communication as well as oral communication. If we can have that text available, we can definitely create some sort of predictions from that. But I don't think any doctor or any organization will be taking the kind of risk or taking the responsibility of just using machines to handle this emergency type situations yet. Anand, actually, you are muted. I can't hear you.
Okay, can you?
Yes.
Yeah, Sachin Patil has question, Praveen Kumar has question, Hemant Kukade has question, but all those I will pass on. I will now hand over the mic. Ameet, thank you very much for such a lovely presentation. People
Thank
are
you.
really
Thank you, everyone.
learn a lot. I'll hand it over to Sri Ajit Jaukar. Ajit Jaukar has initiated mentoring in AI program on Garje Marathi platform, for which we have got excellent response. He has already taken batch of 6 people, six entrepreneurs whom he is mentoring till end of September. Next batch will start in September. Over to Ajit Jaukar, who is professor in Oxford University. Ajit, please take over and then we will close the meeting.
Perfect. Thank you. Thank you, Anand, and thank you, Dr. Amit, for the great presentation. So my comment really is about looking at it from the presentation of your insights. So obviously it was very useful. I think the most interesting thing was that you were very realistic about AI. Yes, I mean the fact that you started off with a quote which looked like Donald Rumsfeld, meaning I know known unknowns and don't know and don't unknowns kind of stuff. Yes, I think that is very truthful, because I think that is something very needed in the industry today to talk about what are the limitations of AI. The other thing, the other temporary word about explainability, which again is a very important to get across. And of course, democratization of AI, which I think will be a big thing going forward, and also explaining the spectrum of possibilities. When someone like me is on the sort of the engineering IPR kind of AI end of it, but it is completely democratized to everybody. So thank you very much. I mean, those are my 3 points with that, and look forward.
Thank you. Thank you very much.
Thank you, Amit. Thank you, everybody. We will end the meeting now. And